What's up, guys? So today we're gonna talk about how to implement firewall rules for your Podman networks. Okay, we are going to use nftables for this, which is I believe the standard solution that Podman 6 is adopting. It's already the default in Podman 5 something, I believe, so it should work out of the box. Make sure that you have nftables installed and enabled on your Linux distro for this to work. I will show you how what exactly you need to do to be able to set firewall rules for your Podman network. This only works with rootful Podman, so it doesn't really work with rootless as far as I know. And I will show you some basic rule definition with what we've designed for Grate. Okay, let's get into it. So we're gonna talk nftables. We're going to create a table called inet Grate. This means that inet, it means that this table is for IPv4 and IPv6 in a single table, right? And then Grate is the name that we gave our table. We're gonna disable IPv6 traffic by default because IPv6 doesn't have a NAT like IPv4. If your device in your network has an IPv6 IP and there is an IPv6 route to the public interface, the internet, right? Essentially your device will be exposed to the internet as far as I understand. Okay, so I disable IPv6. I never used IPv6, unfortunately. I'm very curious to set it up, but it's usually a hassle. Then we are going to drop all connections to link local and private IPv4 addresses. This means your local network and containers and all that. And then we are going to accept all traffic based on the whitelist.conf file that we've got. Okay, so let's take a look first at our just file, and let's look for how we create our Podman network. So this is just, you know, making sure that we start from zero. When we create our network, we disable DNS because we've got our own custom DNS, but this is not related to the firewall. We set a specific subnet. So in our case, the subnet is defined here. It's 10.41.00/24. So all IPs can vary within the last part of the IP. For one is for AI, you know, let's speak for AI. And then we also export the interface that the Podman network connected to, the interface that was created. And we also set up a few hosts that we're gonna use for other stuff. But so this will tell us the interface. The subnet is already known, but we might need the interface, okay? And most of our firewall rules will be based on this interface. And this is why we need to run this with sudo. So let me just show you a quick example. Let's say that Podman network, I've got an isolated network which I'm not using, so I'm going to delete that. So we start from zero, and I'm going to create a Podman network called test, okay? And this is rootless, okay? So I'm running as my own user. And now I'm gonna run an alpine with this network, okay? Okay, this is not what we want to look at. What we want to look at is whether this created any Podman interface, and it did not. So we cannot easily filter this with nftables, okay? So now what we're going to do is just remove this network. And now let's recreate the network with sudo. So first let me sudo Podman network list. I've got just the defaults as well. Now let's create the test network in root, and we've got Podman If we go here, nothing here, but if we start sudo podman run, if we run a container on this network, then we'll see that it created an interface podman1. And this is exactly what we are exporting into our workspace. If you go in here, we don't have it now, but let's say that I'm going to run, let me just delete the network, and let's run our base container. Okay, and if we go here and just list, we've got podman1 once again, and now we'll see that this was exported to this file, which helps us set our firewall as well, because it's exported to this vars nft. Okay, so we've got the podman iface variable with podman1, and we also got our DNS server. This is for specific rules. Okay, this one is critical. So now let's take a look at the firewall, the ensure, not ensure firewall, but load firewall rules. Okay, and what we do here is first we set the NFT variables that I just showed you. Okay, I think it's something like this. It's, as you can see, we just get the iface and DNS files. These are created in the appropriate time. And then we check the file to see if the rules are correct, and then we load this file. Then there are some dynamic rules that we add here from the whitelist. Okay, and these you can either define a .nft file which has a particular structure, or you can define the rules using the command line, which uses a similar syntax, but we only do this for dynamic rules. We've got our base rules defined under grate.nft. So as you can see, what we do first is add the inet Grate table. If it exists, this is ignored, and then we immediately flush the table. This is in case the table doesn't exist and we try to flush it, there will be an error. But if we add the table first, there is no error if it already exists and it's flushed. Okay, then we include our variables, so they are available within this context, and we set to create our table inet Grate. This is the only block that we have here. Okay, then we have three chains, one for inputs, which is, and remember, the firewall is running on the host, it's not running inside the containers, so be careful not to block traffic for your own machine, your desktop or workstation or whatever you're running on. So we've got our input for incoming connections to the host. Okay, we've got our forward, which is our main block, our main chain to add rules to. Then we've got our output chain. As we can see here, the default policy is to accept, and this is because we do not want to override rules that have been defined for the host. But if you noticed, our last rule is always to drop all connections for the Podman interface, which is really what matters here. So your containers will always communicate through the Podman interface. So if you drop all, you are in fact denying all by default for your containers, right? And as you can see, we drop all IPv6 connections. There is this city state which accepts, which keeps state for some connections. So when you allow an incoming connection, you will also be allowed the outgoing connection that is related to that connection. So the firewall will keep a table with states, and this is the rule that you set, so state is respected. And then we drop all ICMP, so all ping, even for IPv4, is dropped on the Podman interface. Then we've got something similar for the output chain. Okay, it's very similar. And then for the forward chain, again, policy accept by default. Everything that is IPv6, either if it's incoming on the interface, on the Podman interface, or outgoing on the Podman interface, will be dropped. We accept, we keep state, right? We make sure that this is dropped first, because if everything is to be dropped, don't add it first, right? So this is evaluated top to bottom. The first dropped one will be the one that is respected. And so in here, for any connection that goes to a different interface other than the Podman interface, so it goes to some other device on your network, this will be blocked by default. This will be dropped. Any outgoing ping request, just wrap this, will be accepted. Okay, although we block drop capabilities for ping, and I believe it's also blocked with no, I'm not sure. So this will really not work, but if you only have the firewall, you'll be able to ping, and this is essentially used for the debug image that we've got for the debug network, and we want to be able to ping to the outside, but never our network, our internal network, right? Then we've got a rule to let traffic run for the DNS server. And as you can see, we've got almost what feels bidirectional rules. And we've got this keep state, this is state. So why do this? Because in fact, we've got two containers running. One is the actual DNS server, and that one needs to connect to external DNS servers. And the other one is the connections to this internal DNS server from other containers, okay? And so that's why we've got two types of rules. So this is essentially a UDP and TCP rule, and UDP and TCP rule. This is to be able, for the DNS to be able to access the exterior, and this is for us to be able to receive name resolutions from our internal DNS. Okay, everything else is dropped. This is just an experiment. We might want to access port 80 or 443, but in fact this is done with dynamic rules. So let's take a look at how the dynamic rules actually work. So our firewall is loaded. If we list tables, we'll find one for firewall D, our firewall CMD, one for NetAvark, which is the network protocol for Podman, and one for our Grate software, right? So let's see, let's try to list all the rules in Grate. And as you can see, there are a lot more rules than ones defined on the file. And the first rules that are added to the forward chain are rules that are derived from our whitelist. And I added a comment with the actual line in the whitelist that generates this rule. So for instance, when we add openrouter.ai 443, the IP will be resolved. This is not a feature that nftables has, but instead what we do, let me check. What we do here, and I believe it's here, is call get end a host v4 with the given domain, and this will give you the list of IPs resolved by the system. So let's test this command. This uses the available DNS commands. So let's test this, for instance, for this. Okay, there is this doesn't exist. I think I removed this, but let's try this. Okay, and you get a list of IPs, and essentially what we do is just, you know, extract the first element and then sort with U, and we get the unique IPs, and then I think we use xargs to put them on a single list, you know, and format it correctly so it can be added to IP destiny address here. Okay, and as you can see, there is a comment here with the domain and the ports. This comes from our whitelist. And if you want to, if you need to enable other ports, you can, you know, add them here. They will be considered for all systems, including the no profile, the DNS allow list, and the firewall. Okay. And so let's go back to here. As you can see, this creates an external connection. This only works for external connections, so not inside the containers. Okay, but this will open the ports before it sets any other rules. So these will take precedence. And as you can see, the IPs are added here. If the IP changes or there is some system, you know, some round-robin system, hopefully you can just reload the rules, and you can do that with load firewall rules. If you want to see which rules were added, you can use -v or -- verbose, and this will reload the rules, okay, and re-resolve the IPs, and there you go. And I think this is it for the firewall. I don't know if there is anything else I can add other than this. Make sure that if you stop your services, make sure that you don't leave the firewall running. So once you stop it, it should, you know, clear this up. But if for some reason, and this will need ensure network, this will need all this, but let's say that I only had the firewall running and the Podman interface is here, and for some reason I reuse this Podman interface, which is unlikely, but let's say we did it. Make sure that you just unload firewall rules, okay? And in this case, I'm also going to remove the network and stop the DNS, which I think is already stopped, okay? And then we are clear, okay? Like I said in the last videos, this is not the most user-friendly approach, but you know, this code is not meant as a usable tool yet, at least. And there you have it, a very lightweight introduction to nftables and Podman Networking. If you want to design firewall rules for Podman, as far as I know at least, you need to do it as root, so the bridge interface is created and you can filter it. I think there is another command, Podman unshare, I believe, but I wasn't really successful in using it for rootless, maybe in the future, and I'm sure the guys at the Open Containers Initiative are working actively to improve everything around this. I know that Ramalama has their own sandboxing going as well. So this is a very you know, active problem that we need to solve, particularly because security became a major concern with AI in the last few months. So this is also why I never wanted to run an AI agent natively on my machine. Even with no, I felt like I was potentially putting my privacy, my network privacy, in breach. So I wanted to, you know, develop these skills to be able to add some control on top of it. And now hopefully you can too understand and add some sandboxing, some extra measures to, you know, contain your AI agent or other software. Well, until next time, keep working on our systems engineering skills, and I'll see you.